All right, we're going to get started. So BG, you can unmute yourself whenever you want. And I'll start with a quick intro. So hi everyone, I'm Ken from Cronos Labs, and I'm pleased to welcome BG from SubQuery, as well as Emily from Cronos Labs on this stream. So today, what we have in store for you is developer workshop that aims to help any dapp creator who is interested in incorporating various types of blockchain data into their applications. Both Cronos EVM and Cronos zkEVM are supported by SubQuery. And so the main goal of today's workshop is to present what you can do with SubQuery and demonstrate quick starts, which is what BG is going to present. Before we go there, a few words about Cronos for anyone who's joining, who's new to Cronos. So Cronos is one of the leading blockchain ecosystems in the world, built in partnership with Crypto.com, as well as more than 500 application creators who are building use cases in DeFi, NFT, and Web3 gaming. Cronos as an ecosystem consists of 3 chains. The latest one, Cronos zkEVM, is a layer 2 on top of Ethereum, powered by zkSync technology, launched in August, so very recently, and already showing $50 million of bridged assets from Ethereum. Second network, Cronos EVM, a layer 1 EVM compatible, built on the Cosmos SDK that has been now around for several years. Cronos EVM has more than $500 million of total value locked, more than $2 billion of user assets that are securely hosted by the chain, dozens or even hundreds of applications. And finally, Cronos POS, which is what we call the layer 0 of the Cronos ecosystem, in the sense that it's the chain that guarantees in a decentralized manner the security of CRO, the gas token, and it's also a Cosmos chain that's very high performance for payment and NFT trading use cases. So today we'll talk mostly about the first 2 chains, Cronos zkEVM and Cronos EVM, both EVM compatible and absolutely designed to support any kind of decentralized application. With that, I will hand over to BG, who will introduce himself and proceed with the presentation. Hi, BG.
Hi, everybody. Hi, Ken. Hi, Emily. Hi. Yeah, excited to be here. Excited to talk about data indexing. I'm representing SubQuery in developer relations initiatives, and probably, important to say from our side that we're going to be attending DEF CON. So if you're there, feel free to reach out. As Ken said, we support all 3 networks. And the goal of today's workshop would be to first explain what indexing is, and then proceed to something that I can show you, something more practical, like a demo. So I have prepared these slides that I'm going to share now. You should be able to see them now, right?
Yes.
Yep.
That's great. So, all right, without further ado, I'm gonna start. So SubQuery is a end-to-end indexing solution. So what does it imply? It implies a SDK, the managed services, and a decentralized marketplace. So the managed services in a decentralized marketplace, or what we call a SubQuery network, are essentially the deployment options for SubQuery indexer, whereas the SDK is essentially an SDK to build an indexer. And we're going to be only focusing today on the first part. Yeah, I'm also going to be showcasing you the starter Cronos zkEVM starter project that I've launched and managed services. So you can also see how can a project be deployed. So I'm going to be giving a couple of words of about the indexing, the process of indexing. What is it and why is it even needed? So let's say as a developer, you've deployed your smart contracts, which throughout time have been called many times, and the transaction was executed there, and the events were emitted, certain logs. And you're interested in building a dapp, which is giving exposure to blockchain data. Not only the blockchain, that probably would be more correct to say a historical blockchain data, a data that like appeared a million of blocks away, for instance. So how do you get such data? There are several ways to do it. So from your dapp, you can directly connect to an RPC node and try to filter from the vast amount of data your specific events from your specific smart contracts, and going back in the past blocks and trying to find the relative data there. So you can imagine that it's going to be quite a computationally hard task for a client application to achieve, especially if you're using a dapp from a mobile device, for instance. So that's where you need indexing, and essentially that's the main purpose of like the indexing use case. So essentially, the indexer is a third-party program, a wrapper over the blockchain that is taking some time to index the historical data of the blockchain. Obviously, it's not happening momentarily, especially if the blockchain is quite big. And then just by after the indexing, after going over some of the blocks, it is giving a convenient to use API to the client application that could just directly call it without the necessity to query the blockchain and to look into the transactions directly from the RPC node. So it's essentially like filtering that is done in advance and asynchronously. So you can see the representation of it on the slide. So essentially, we're having networks, many networks. We're having the SubQuery SDK indexer that is essentially only taking the relative data, your specific smart contract data, and saving it to a database, a local database, where the same indexer, for instance, is being hosted. And then an access to this database is given via a GraphQL interface, or it could actually be like it could be a different interface here. So it could be Metabase, for instance, for the convenient no-code business intelligence, or it could be direct SQL queries. Doesn't really matter. So at the end of the day, it's just a database that is being queried without the necessity to query the blockchain RPC. And you can use such kind of data for like many purposes. Like if you're building a blockchain explorer, any kind of dapp, a mobile app, the analytics page on your dapp, that's where you need the indexers. And SubQuery is having many unique features when it comes to indexing. So first of all, it's completely open source. So feel free to contribute. You're welcome. You're always welcome to do it. And not only the code is open source, but the requirements and features are also there. So you're able to affect the development even before the start of the development. It's very easy to launch. It's completely Docker friendly and completely completely local setup friendly. You don't actually need any node to be running. So you could use a SubQuery indexer with any public RPC node out there. It's really simple to configure because only 3 types of files need to be set. I'm going to be giving more details about those files a little bit later. SubQuery is customizable. Every SubQuery project is a TypeScript project, and essentially you're having the freedom of customization. You're having the same freedom of customization as if you were developing anything in TypeScript language. So yeah, essentially you can build anything. It's very fast. It's feature rich. It's real time. Could probably be interested in real time if you're interested in getting up-to-date data from the latest blocks, and without the necessity to constantly pull the API from your client. So instead, you can just establish a WebSocket connection and get your data on the fly. Another unique feature is multi-chain support. So as you can guess from the name, essentially with the SubQuery index, you're able to create this centralized entity that would be able to index data from multiple blockchains. One of the use cases for it would be to track the cross-chain execution, for instance. So let's say you're having a transaction executed like throughout like 3 Cronos blockchains. I don't know, it could be a bridge transaction, anything. And if there wasn't for a multi-chain feature, then you would probably need to set up separate indexes and set them properly for any network that you're willing to track the execution of transaction in, and somehow try to create from your app query 3 different API endpoints. But with multi-chain feature, you could actually have a single API endpoint that you can query, and that could orchestrate essentially the handling of data. So it's a very convenient tool to be using. It's also very flexible. Obviously, if you're interested in indexing a blockchain, and every time without the modification of the code, every time launching your indexer, you would have the same set of data index, because like blockchain data is deterministic and immutable. But you're not only limited to blockchain data. You can also import the third-party libraries and make the external calls, for instance, to fetch the prices or the equivalence. And yeah. Finally, it's compatible with many blockchains. So there are more than 200 networks that are officially supported. By official support, it means that there are the starter project in place, as well as the templates, which mean that you can launch and scaffold a SubQuery indexer project from a CLI. But like what's supported, what's being supported in its essence is rather the architecture of the blockchain than a specific blockchain. So any VM chain that Cronos may have in the future will be supported on default, as well as any Cosmos SDK-based chain. So and that being said, all of the 3 current networks in production are being supported by SubQuery. There are certain prerequisites to run your SubQuery indexer locally, so you'll need Node.js, Docker installed, if you want to be launching it via Docker, obviously, and you'll need a SubQuery CLI. You can see the instructions, the installation instructions here. How does the indexer work? So in regular scenario, you would first need to initialize your indexing project. You can do it with the command subql init, and then you'll just need to build. And as I said, there are only 3 types of files that need to be configured. A first one is a schema file as part of a schema GraphQL file. And essentially, in this file, you're specifying the API that your index is going to be having. So since it's GraphQL, then the API is going to be GraphQL as well. A second type of file is a project manifest file, which defines the smart contracts that you index. And essentially, in this file, you are giving the instructions to the indexer to look into the specific primitive of the blockchain. It could be a block, it could be a transaction, it could be a lock, it could be like event or messages in Cosmos chains. And once those primitives are identified, then they're fetched by the indexer. And when they are fetched, they're passed to a handler, a TypeScript function that which goal is essentially to handle the raw data that could be fetched from a blockchain, somehow modify it if necessary, and just save it as part of a entity or a table, which is automatically generated in a database based on the schema of a schema file, of a GraphQL file, essentially. And when you have it populated, then you're essentially saving the subset of data, of blockchain data, in a structural form, in the form that you want to be having it, in the local database. And obviously now the apps don't need to look for the specific data in blockchain. They could instead query the single API endpoint, and obviously the app's going to be able to find data more quickly than trying to query it from the blockchain. And finally, you just query your data. You don't have any limits when it comes to the interface that you're going to be using for querying in our example. And by default, you'll be using the GraphQL. But again, anything that is relational database friendly would work in this case. So I'm also having a small demo prepared. I'm wondering if there are any questions that I can answer before we go to a practical part.
A few questions in the chat. So first, I think people are requesting videos to be turned on. Secondly, Ask Blockchain is asking, so does it support Cronos?
So it supports all the 3 networks. So SubQuery index is rather supporting the architecture, not the specific networks. So since Cronos is the Cosmos networks, it's being automatically supported. Same goes with zkEVM and TVM. Those networks are supported by default, by SubQuery SDK.
All right, you can continue.
All right. So I'm going to be going over the example of the starter project that you can find via this link. So this is a starter project for zkEVM, and if you would run subql init CLI command in your terminal, you would be able to find it. So this is, here you can find the code. Here you can find the folder in the GitHub repository, a pre-configured for zkEVM only. So we're just going to be indexing a single network today. So we're not going to be creating a multi-chain project trying to index data from all the free networks, but it's theoretically possible. So yeah, the focus today is a Cronos zkEVM, but all the other networks are supported as well. Very important to understand. And what we're going to be indexing is the approvals and transfers of CRO token in zkEVM. So this is the address of a smart contract. Here are the transactions, and yeah, we will be able to index data and then cross-check its correctness, or like anything that we index with the Explorer. So let me quickly switch to my VS Code application. All right. Hopefully it's visible now. So, as I've previously been telling, there are 3 types of files that need to be configured. The first one is a schema file where we specify the API that we will be using and querying the indexer from. So essentially, we're having only 2 entities that we're interested in indexing, which are transfers and approvals, and each entity is having its own set of properties, like transfers having the receiver, the sender, whereas approval is having owner and sender, for instance. Think of it as a table in the relational database. So for each entity, we're going to be having a database. A second type of file is a manifest file. So here we are configuring the networks that we want to be fetching the raw data from, as well as like what data we would want to fetch from a blockchain. So here we set the chain ID of zkEVM. Here we set the endpoints, which could also be any private RPC endpoint. Here we set a specific smart contract that we want to be indexing data from. And finally, we set the handlers. Just going over the example of a first handler, Ethereum handler kind.call means that we want to be fetching the calls over transaction from a blockchain, which is of the specific method, approve in our case. And once it's fetched, we want to be passing this transaction as an argument to a handler, a function that is called a handle transaction. And handle transaction functions is something that we're configuring as part of a third type of file, a mapping file, essentially. So here you can see handle transaction function, which accepts a transaction as an argument, approved transaction. Yeah, once we could actually go with the code here. So once it's being accepted, we first print the block number. Then we're want to be asserted that the args are present in the transaction. And finally, we are populating the approval entity or table with the specific parameters of the transaction. So, for instance, for value, we are accessing the first argument, we're then converting it to string, and then we are converting it to a big integer. So essentially, we're having a whole freedom of TypeScript language here. And then we just save it to the database, to the approval entity. And that way, we are connecting the schema file and project file. So we're taking a raw blockchain primitive, saving it to the specified data structure. And this is actually it. So you can go ahead and launch this project locally. So the Docker Compose file is prepared here. It's configured. As you can see, it consists of 3 components, which is a Postgres database to store data, SubQuery node is SubQuery indexer, essentially something that knows how to work with on-chain data and handle it. And finally, a GraphQL, which is essentially interface to get an access to on-chain data. The easiest way would be to launch a command yarn def, which will first do the code gen. So probably, a couple of words about code gen, which is a very important feature inherited from the features of TypeScript blockchain. So TypeScript is having a great type system, and obviously it's leveraged in SubQuery projects. So if you look into a handle function, you can see that it's accepting the transaction of approved transaction type. So how does SubQuery know what is the approved transaction? So SubQuery knows how to generate the types based on the ABIs. So in our case, 0 is ERC20 contract, and we know its ABI. So essentially, if you're having your smart contract with a different ABI, you could also have the types generated automatically and used within your project here. And this type generation is one of the things that is done as part of a code gen process. This is a very useful thing that is, ensuring the safety of execution of your program, leveraging types. Then your project is going to be built, and finally, you're going to have it launched in a Docker Compose. So I've done some pre-indexing. So I've launched this project within the managed services of SubQuery. So managed services is essentially a cloud platform for SubQuery project. So it's very similar if you would be using like AWS or Google Cloud. It's just like very easy to configure, and the SubQuery projects here are very easily configurable and manageable. So this is the simplest interface to start with. And I can now query my data. So same way if I would be querying if I was launching a project locally. So here I can see the GraphQL Explorer, and I can see all of the entities that I can query. So for instance, I can select transfers. Then let's say I just want to be printing all the transfers and all the information indexed so far. So if I press the play button, you can see you can see the blockchain data. So if we just switch to a blockchain explorer and just try to look up the information of this specific transaction, you will be able to see from the logs that this specific transaction was indexed, and indeed a transfer took place. You can see here the smart contract address of CRO. That way essentially you're getting access to the same data, but in the form of the API that you can leverage from your apps. Another, yeah, but obviously not only you can, have those primitives taken from the blockchain as they are, like, shouldn't be really an atomic data. So what you can also do as part of SubQuery or separately within your application, when you're getting the access to this atomic data, you can make the aggregations. So let's say you want to be having a statistics page in your dapp, and you want to be calculating the I don't know, the sum of the amount, the total amount done within a certain time period, like a month. And yeah, you would be able to do it with SubQuery. So essentially, yeah, this is the way how you can configure an indexer. It is again compatible with all of the free networks. So and not only you need to index them separately, you could also do the multi-chain indexing. You can track the execution of cross-chain transactions. It's, again, super helpful if you're building the dapp for a bridge, for instance. And yeah, with that, yeah, I think I should also say a couple of words about the single source of truth, a documentation of SubQuery. So this is the best place to find any technical information about the configuration of your indexer, of any type of the architecture that you want to be working with. It's having the up-to-date information, but if you're still having any questions, the best place to ask them would be in Discord, in a technical channel. I don't really remember its name, but yeah, it's there. I'm sure. So that's it for a demo part. Happy to answer any questions if there are any.
Okay, thanks, BG. Looking at the YouTube chat, I don't think that there are additional questions. Checking on Twitter. No question either. So I think we've covered everything. Thanks a lot.
All right. Yeah, I'm also seeing a small question in the chat. How do you overwrite immutable blockchain data? So SubQuery doesn't do writing; it's only doing reading. And essentially, what it does, it's giving the exposure to on-chain data, but it never writes anything. So it's just a convenient way to set up a data querying, and that's it. So yeah, if there are any other questions, I want to say that it was excited to be here, and yeah, looking forward to the more workshops in the future.